Hey guys, sorry I couldn't be with you today. Hoping to be there tomorrow. Um, you should have finished 3.4 um, in your textbook by now. Okay, and as soon as I can get back, we'll go over questions you may have on that. Um, and today you are doing questions 1 through 18. Let me look. Yeah, 1 through 18 on 3.5. And this section is on systems, which has to do with where the lines cross on the graph and where they intersect. Those would be the solutions of the system, right? But now it's not just lines. So before you had two lines intersecting. Now you have these weird, different exotic shapes going on. So, for example, number one says solve by graphing. Well, I'm not going to do any algebra there. Then you can just go to Desmos, okay, and graph that. Let's see, x plus 2, this is number 1, so x plus 2 plus q, and half x plus 2. Okay, so you can see here that these points of intersection right here would be the solutions, right, for number 1. So it would be 0, comma 2 and negative 2, 0. Two separate solutions because any point of intersection is called a solution, all right, for the system. All right, so that's number 1. Okay, number 4 through 9 you solve by substitution, and 10 through 12 by elimination. So those should look sort of familiar. Let's see, number 4 by substitution. So since we already know that y is x plus 5. Oof. All right, we're going to take that x plus 5 and plug it in for y on the bottom equation. And we have x squared minus x. Okay, and then you're solving this thing, which now that we know completing the square and also the quadratic formula, we can solve any quadratic. So we would just get everything on one side, setting it to equal 0. So here we have this. And I would look and see if I can factor this, which it looks like I can. If not, you'd have to complete the square, but I'm thinking what numbers multiply to get negative 3, and since that's a positive and a negative, then they're going to subtract, and I want them to subtract to get negative 2. And I want the bigger one negative, so that would be that. So then my solutions would be negative 1 and 3. All right, and I just solved that system. Oh, wait, no, I didn't, because what do I still have to do? Okay, I need to take these and plug them back in. Okay, plug them back in for x, and notice that you're going to have 2 now. So I'm going to take negative 1, and you can use either equation, just as before. I'm going to do the top one because it's easiest, so y equals negative 1 plus 5, and y equals 3 plus 5. See how I did that? So I just plugged these x's in for this one into the top equation, and then this one into the top equation, and I'm going to solve to get the y. So when x is negative 1, y is negative 1 plus 5, that's 4. And when x is 3, y is 8. And that is your solution. Does that make sense? So an x and a y, and if you have 2 points, then you need 2 x's and 2 y's. All right, and that would be number 4. Okay, let's see. How about number 10 by elimination? So, technically, when you see these in the wild, you can choose whatever method you want. Of course, you can graph. So it's just important that you know how to do these. Don't feel obligated. If you see an easier way, you can use the easier way. But you will want to make sure whatever way you're using is available to you on a test, right? So here's number 10, and I'm using elimination. So that means linear combination. It means I want to add these together and have something cancel. And you guys hopefully remember that if I add, if I'm about to add these together, and oops, it's a little tough over here. Let's see. If I'm about to add these together and they're not, something's not going to cancel, that's not going to help me, is it? But right now I can see that these y's will cancel. Very important that I have only one variable remaining because, obviously I'm going to be left with something to solve here. So here's what I get for 10. If I had canceled out the x's, that might not help me, right? Because I have a y and an x, and that would be, in that case, a parabola. So wouldn't give me a solution. So what would you do here? You might could think about graphing or solving by factoring. We should always ask, the first thing is, what can I take out of both of these? Which would be a 2x. And if I take a 2x out of that, I have x left. And if I take 2x out of this, I have 2 left. So here you have two roots, right? X equals, well, 2x equals 0 is 0, and x minus 2 equals 0 is 2. Okay, and that's number 10, right? Don't forget, you've got to plug in the x. So here I have 0. I'm plugging in 0 for negative x. I'm using the bottom equation, all right? That's the easy one. So 0 plus y equals 5, and that's y equals 5. Oops, I need my y equals 5. And negative 2 for x is 2, plugging 2 into that bottom equation. So that's negative 2, adding 2 over, y is 7 here, right? And a little bit important, make sure that, it's obvious that these are together, okay? Make sure it's obvious that these are together, okay? You can't say x is 0, y is 7. That's not a solution. This is a coordinate where they intersect, and this is a coordinate where they intersect, all right? So make sure that you're clear on the coordinate pair, like that. All right, does that make sense? That's about it for this section. This is just the first part of it, and we're not going to go into detail at all on this section. This is kind of superfluous stuff, but mostly review. So hopefully you'll be able to breeze right through this, and then I'll be back on Wednesday to go over part 2 with you. Okay? So look forward to seeing you guys again soon.